Hello everyone, I am Nikita Kulkarni from Dharam Singh Desai University and I, along with my partner Yusi Nandasana, are here with the presentation on speech recognition devices. As the topic says, this is a device that enables people to verbally communicate. We are lucky enough that we are able to communicate easily on our own, but there are people who have difficulty in doing this. So, this device is used, which is also known as the voice output communication aids, that are electronic augmentative and alternative communication systems that are used to supplement or replace speech or writing for individuals with speech impairment. As we all know that the first person to use this device was Stephen Hawking. Hawking was unable to speak due to a combination of severe disabilities caused by ALS and an emergency tracheotomy, which included death of neurons in the patient's brain. It results in muscle twitching and a gradual damage of muscles that leads to difficulty in swallowing, speaking, and eventually breathing. So, here are a few glimpses on the working of the device. Speech generating devices can produce electronic voice output by using digitized recordings of natural speech or through speech synthesis, which is the artificial production of human speech. It may carry less emotional information but can permit the user to speak normal messages. A computer system used for this purpose is called a speech synthesizer and can be implemented in software or hardware products. For example, if a person chooses the icon on the device that corresponds to an apple, so he or she can push the button with the picture of an apple. A recorded voice is generated that says, I want an apple. In general, it is a text to speech system that converts normal language text into speech. Other systems render symbolic linguistic representations like the phonetic transitions into speech. But a synthesized speech can be created by concatenating pieces of recorded speech that is stored in a database. SGD is divided into three parts. First, input, second, interface, third, output. Here, input is feeding the information into the machine, which also happened to be the most challenging element in Hawkins' case. Like many other ALS patients, he had little control over his muscles, which means that he couldn't just type out words or click some buttons to input the information. This was achieved by an infrared switch mounted on his spectacles that caught the slightest twitches or movements in his cheek. The system can be seen in the picture. When his condition was better earlier in his life, he used to press a clicker using his thumb for input. However, he eventually lost control of the nerves that controlled his thumb muscles and had to use other methods of input, hence the infrared switch that traced the movements in his cheek. Second, the interface. The next part involves forming the moves a cursor across the keyboard by either moving through the columns or rows. When it reaches the desired word, Hawking could stop it with a twitch of his cheek. Individual letters were selected in this way to form the words and then sentences. Furthermore, EZ keys also let him move the pointer in the Windows computer that he used. To make things easier still, the software also included an autocomplete feature very similar to what we have in the smartphones and tablets that predicts the word without requiring Hawking to complete the spelling of the entire word. The further information would be shared by my partner, Yusi Nandasana.
Speech generating device divided into three parts: input, interface and output. Now we will discuss about output part. It is the last and also easiest one. Is speaking the complete sentence out loud. Hawkins used a speech synthesizer that spoke the sentence once and it had been approved. It did have an unmistakable accent which described by American, Scottish and Scandinavian. Characteristic: portability, barcoding to environment, self-training and frequency. In portability, users can easily carry the device and use it as an extension of the body. barcoding the environment. The number of attached barcode is infinite. Self-training. Users can literally take their tools in their own hand. This makes the device is good candidate as a tool for homework and self-training. Frequency. Person will strengthen the link between stimulus and the word, making it more likely, so that he or she will be able to generate the speech. By using this speech generating device, patient is also able to talk, compose speeches, lectures and research papers, browse the internet and write emails. There are two types of display device: fixed display device, dynamic display device. Fixed display device, in which symbol and item are already fixed in particular format. In dynamic display device, it is a touchscreen device that generates electronically produced visual symbols. Also, it allows a child to access a large amount of vocabulary in one device. Now we will talk about challenges. Programming of dynamic speech generating device is done by augmentative communication specialists. Specialists are required to cater to need of the patient because the patient usually choose what kind of word they want. For example, patients use different phrases based on their age, interest and disability. Therefore, content organization is extremely time consuming.